we are going to study the subject of physics. In that, let us first of all talk about what is physics. So, basically, physics is the branch of science which deals with the study of nature as well as the properties of matter and energy. For designing any law of physics, a scientific method is followed, which includes the verification with experiments. The physicist attempts are made to measure the quantities with best accuracy. Thus, physics can also be defined as the science of measurement. So, let us learn some basic concepts of physics, such as what is a physical quantity. All the quantities in terms of which laws of physics can be expressed and which can be measured are known as physical quantities. The examples of physical quantities are distance, speed, mass, force, etc. The another important term is measurement. In our daily life, we need to express and compare the magnitude of different quantities. This can be done by measuring them. Measurement is the comparison of an unknown physical quantity with a known physical quantity. You might be purchasing some kgs of fruit, purchasing some liters of milk. Okay, so that is kgs and liters are all the measurements. Okay. Now the units, the known fixed physical quantity is known as a unit. As I told you earlier that kg of fruit, liters of milk. So these liters and meters, they are the units. Okay. The quantity used as a standard for measurement is known as a unit. So this is the example of some typical measurement. So these are these three basic terms that we need to understand before understanding the physics. Now let us understand how a unit should be. Means what are the requirements of standard unit. So there are basically 7 parameters which are required for a standard unit. The first one is it should be universally accepted. Means it should be accepted in India, in America or throughout the world. Okay. Second is it should be definite and well defined. The third one is it should be readily available as and when required. Okay. The fourth one is it should be easily compared with other similar units. Okay. Next is its size should be such that quantities measured with it should not be too large or too small. Okay. Next is it should be easily reproducible and non-perishable. Furthermore, it should be invariable, means fixed with time and place. Means if you go to the America, the temperature conditions are different. Okay, but the measurement quantity should be fixed. Means the dimension, the meter, whatever the length of meter is there, it should not be changed with the time and place. Okay, so that is the meaning of that. Now, there are basically two different types of unit. First is the fundamental unit and another one is a derived unit. So let us first of all talk about fundamental units. A quantity which is independent of other physical quantities, okay, is known as a fundamental quantity. Means in mechanics, mass, length and time are the three fundamental units. The unit of fundamental physical quantity are known as a fundamental units. Next is the derived units. So there are derived quantities. Means let us talk about force. Force is nothing but it is a product of mass into acceleration. Okay, F is equals to ma. You all are aware about that. So it is a derived quantity. Again, acceleration. What is acceleration? Acceleration is velocity divided by square of the time. So it is derived from that. Velocity, it is nothing but meter upon second. So this is how the derived quantities came into existence. So physical quantities which depends on one or more fundamental quantities for their measurement are known as the derived quantities. So let us take comparison between fundamental units and derived units. The units cannot be further reduced to an elementary level. Okay? Means if we talk about mass, there is no subpart. But if we talk about Newton, it can be said as kg meter upon second square. And for mass, only kg is there. Okay? So these units can be reduced into elementary levels that are composed of fundamental units. Next is, these units cannot be expressed in terms of derived units. Okay? Furthermore, derived units can be expressed in terms of fundamental units. There are only 7 fundamental units in the existence, okay, in the metric system or in the SI system, whereas there exists a large amount of derived units in the metric system. So this is the basic difference between fundamental units and derived units. Besides the 7 basic units, there are 2 more units that are defined as plane angle and solid angle. So let us first of all talk about plane angle. Plane angle d theta as the ratio of length of arc to the radius. As you can see in the figure over here, that ds is the length of arc and r is the radius, whereas d theta can be written as ds by r and its unit is radian. For as far as the solid angle is concerned, solid angle is defined as d omega as the ratio of intercepted area dA of a spherical surface described about the apex as the center to the square of its radius. As you can see in the figure, dA is the intercepted area and r is the radius. So d omega is equals to dA upon r square. So the unit for the plane angle is radian with symbol RAD, and for solid angle the unit is steradian, STERADIAN, and with the symbol is SR. Both these are dimensionless quantities. Okay. Now next topic is what is the dimension. As we have talked that dimensionless quantity. Now what is the meaning of dimension? Let's further discuss over here. That power of a base quantity that extends to its expression of a physical quantity is called as a dimension of the quantity in that base. For example, if we talk about if we talk about force is equals to mass into acceleration, means mass into length into time raised to minus 2. So that is how for force m raised to 1, l raised to 1 and t raised to minus 2 came. So that is the dimension. Now next is a dimensional formula. An expression for physical quantity in terms of base quantity, that is mass, length and time, are known as a dimensional formula. As we have talked about the force, that is m l raised to 1 t raised to minus 2, that is the expression or the dimensional formula for the force. Now next is the dimensional equation. So whenever the dimension of a physical quantity is equated with its dimensional formula, we get a dimensional equation. So let us talk about some basic quantities and with their dimensional formula and their dimension equation. So the first quantity over here which we are going to discuss is the speed. As we all know, speed is defined as distance upon time. So distance per unit time, that is m0 l1 t raised to minus 1, and the unit is and the dimensional formula is like that, m0 l1 t minus 1, and unit is meter per second. Next is acceleration. acceleration is equals to distance upon time square. So m0 L1 t raised to minus 2, and the unit will be meter upon second square. Third one is the force, mass into acceleration, as we have already discussed, kg meter upon second square. We have described the unit as Newton in order to give respect to the inventor of that, Sir Isaac Newton. Okay, that is mass into acceleration, m1 L1 t minus 2. Furthermore, the next quantity is work. Work is equals to force into distance. So the unit is m1 L2 t raised to minus 2, that is dimensional formula, and the unit is joule. Furthermore, the next quantity is power. Power is nothing but work divided by time. So m1 L2 t raised to minus 3, and the unit is watt, in the memory of the James Watt, the founder of that. Next is pressure. Pressure is nothing but force per unit area. So m1 L raised to minus 1 t raised to minus 2, and the unit is Pascal. And the next one is surface energy. Energy per unit area is the surface energy. So that is joule per meter square. m1 L0 t raised to minus 2. That is joule per meter square. And the last one is the momentum. Momentum is nothing but mass into velocity. m1 L1 t raised to minus 1 kg meter per second. So this is all about some basic physical quantities. Okay, that's it for today, guys. Thanks for watching.